Welcome to today's lesson. Today's lesson, we're going to start off with our unit on quadratic equations. Lesson number 1, we're just going to continue going over factoring polynomial expressions. Okay, so let's get started. Example 1 says, is d minus 4 a factor of 3d squared plus 13d plus 4? Okay, the easiest way for us to solve this is we are going to factor the 3d squared plus 13d plus 4 to make sure that d minus 4 is a factor. If it's not a factor, then we can confidently say that d minus 4 is not. Okay, so let's get started. We need to figure out the parts where it adds to equal 13. And remember, it needs to multiply to be equal to, well, it's 3 times 4. Remember, it's the a value times the c value. So it's the 3 times 4, which is 12. So we need to find the factors of 12 that multiply to give you 12 and also add to give you 13. Okay, those two numbers, okay, will be 12 and 1. Okay, so those two numbers, we're going to split the 13d so that it's 12 and 1. So we have 3d squared plus 13d plus 4, and we're going to break up the 13d so that it's 12d and 1d. Okay, so again, from last time, we're going to separate into two different brackets and factor the two brackets. So the greatest common factor between 3d squared and 12d will be 3d, and all that's left is d plus 4. And the last one in the second bracket, what's common between the two, will be 1, and then it's d plus 4. This is great because we can see that there are two brackets that are the same, so we can rewrite this to be 3d plus 1, and then d plus 4. Now, to answer the question for example 1 saying, is d minus 4 a factor? Because it is not shown here, we can say that no, d minus 4 is not a factor. Okay, so there you go. So make sure that you still answer the question that's being asked. So the question was, is d minus 4 a factor? And we say with a sentence at the end saying, no, it is not. Moving on to example 2. Example 2 will be a few different ways we're going to factor. So we're going to factor with rational coefficients. So now it's going to be a little bit different because we're going to be dealing with fractions as well as decimals. Okay, so let's get started. A, x squared minus 1.5x plus 0.5. So right now the 1.5 and the 0.5 are a bit troublesome. So what we're going to do is we're going to remove them. Okay, so we're going to factor something out. So what we're going to do is let's multiply all of these by 10. So if we were to multiply, right? So if we were to multiply it all by 10, that means we need to remove a 0.1 from this expression. Okay, so that's the same as multiplying by 10. Okay. Okay, so now I'm going to write 0.1 is now 10x squared minus 15x plus 5. Okay, because we, again, remove the 0.1, it's the same as multiplying by 10. So you're just going to move the decimal place over. Okay? Now, we're going to look at this fraction now, and we're going to take a look at what's the greatest common factor here. So let's make it easier for us. Okay, so the greatest common factor in this new bracket is going to be a 5. So now we're going to factor out a 5 as well. So it's going to be 0.1 multiplied by multiplied by 5. And then it's going to be 2x squared minus 3x plus 1. Okay, so these two you can multiply together to make it one term. Okay, at the same time, we can do the second part where it's going to add to equal -3, but multiply to equal 2. Okay, so those would be -2 and -1. Okay, so those two add together to still give you -3, but still multiply to give you +2. Okay, so now we have 0.5, and then we have 2x squared minus 2x minus x plus 1. Okay, so same thing as before. We're going to split it in half, like so. and factor the two brackets separately. So we have 0.5, 2x. Okay, so in the bracket, it'll be x minus 1. And the second one will factor out a negative 1, so we have x minus 1 as well. Okay, so we have it where we have our two brackets that are the same. So we're going to rewrite it so that it's 0.5, okay? And then it's 2x minus 1 in one bracket and x minus 1 in the other. And that is our final answer. All right, there we go. Excellent. Let's move on to the next one. Okay, so in this one, we have x squared minus 17 over 3x minus 2. So we want to get rid of the divided by 3. Okay, so we're going to basically remove the 1/3, or you can treat it as you're multiplying and everything by 3. Okay, so let's remove the 1/3, which again is the same as you're going to multiply by 3. Okay, so if we're going to remove the 1/3, like so, you're going to multiply everything in the bracket by 3. Okay, so it's going to be 3x squared minus 17x minus 6. All right, so we're going to do what we did before, which is we're going to add so that we get negative 17, but multiply to give you negative 18. Okay, so in this case, it's going to be negative 18 and positive 1. Okay, so we're going to split apart the negative 17, so that's negative 18 and 1. So we have 1/3 multiplied by 3x squared minus 18x minus, or sorry, plus x minus 6. Again, separate into halves. So then we can look at it and go, all right, the greatest common factor between 3x squared and negative 18x will be 3x. So that we have x minus 6. And then greatest common factor between x and negative 6 will be positive 1. And then we'll have x minus 6. Again, this is what we're looking for because we have two of the same bracket, which is the x minus 6. So we can rewrite it to become 3x plus 1 and then x minus 6. That is our final answer there. Moving on to example 3, where we're going to factor using trinomial patterns. So in this one, we have x plus 3 to the power of 2 minus 6 times x plus 3, and then we're going to subtract 16 from everything. Okay, we're still going to factor though. So this is going to look a little different, all right? Because usually, usually we're supposed to get things in terms of, x squared plus bx plus c, right? We'll throw a coefficient in front. Usually we're supposed to have something like this. It's supposed to look like this. Well, currently it doesn't look like this. It has an x plus 3 in bracket to the power of 2. But we can change that. We can change that. We can change this example so that it looks like ax squared plus bx plus c. And how we're going to do that is by using a let statement. So let x plus 3 be equal to a. Okay, so if we change the x plus 3 so that it's equal to a, we can now rewrite it so that it's a squared minus 6 times a minus 16. Well, that's something that looks the same, doesn't it? Looks very similar. Because now we can factor this a squared minus 6a minus 16. So again, same thing. It's going to add to be negative 6 and multiply to be negative 16. So the factors of negative 16 that add up to give you to negative 6, well, that's going to be negative 8 and positive 2. We have a squared minus 8a plus 2a minus 16. So we can split it apart to be a, and then it'll be a minus 8 plus 2 to be a minus 8. So now it's the same. Two brackets are the same. So we can rewrite it so that it's a plus 2 and a minus 8. But remember, a equaled something before. So now we're going to substitute the a, or the x plus 3, back to where a was. So it's going to be x plus 3 plus 2 multiplied by x plus 3 minus 8. And then we simplify so that it's x plus 5, x minus 5. There you go. All right. That right there is your final answer for this example. Moving on to B. So B, we have something that's very similar. Say, let x minus 6 be equal to a again. You can use any letter if you want. It doesn't have to be a. Okay, but I'm just using a just because it's the first letter, okay? So you can use any letter you want. It just can't be x because x is already being used, okay? All right. So if x minus 6 is a, that means this is 2a squared plus 10 times a minus 48. So that means we need add to give you 10 and multiply to equal negative 48. So what are the factors of that? That's going to be 16 and negative 6. Okay, so now that you figured that out, we'll move ahead and go 2a squared plus 16 a minus 6a minus 48. Factor out. Okay, so then we're going to have 2a plus 8. And then we'll factor out negative 6. A plus 8. Okay, simplify it. So now we have 2a minus 6. And then a plus 8. Substitute in. So now we have 2 times x minus 6 again. And then we have x minus 6 plus 8. Simplified to its final form. Okay, so you'd FOIL out this bracket, right? You distribute the 2 in. So this will be 2x minus 12 minus 6. And then this will be x plus 2. And then finally, this should be 2x minus 18. And then x plus 2. And you can factor this further because if there's a 2 common in this bracket. So you go 2, x minus 9, and then x plus 2. There. Okay, moving on to C. So let's do the exact same thing we've done before with a let statement. So let's do let, and let's use another letter other than A. Okay, let's try Z. Okay, let's try Z. By the way, that's how my Z's look. Okay, so let's have Z equal 2x plus 5. Okay, so now that we have that, we're going to rewrite it so that it's 3z squared plus 10z minus 8. Okay, so we're going to rewrite this now with the adding and multiplying. So it's got to add to give you positive 10, but it's got to multiply to be negative 8. Or sorry, negative 24. So the factors are going to be, again, 12 and negative 2. Okay, so let's substitute those in. So we'll get 3z squared plus 12z minus 2z minus 8. Okay, separate the 2 and factor. So this is going to be 3z. And so in the bracket, we have z plus 4. And then we're going to factor out a negative 2. This will be z plus 4 as well. Rewrite so that we have 3z minus 2 in one bracket, and then z plus 4 in the other. Substitute the values back in. So we get 3 multiplied by 2x plus 5 minus 2 in one bracket. Okay, and in the other bracket we have 2x plus 5 plus 4. Okay, distribute the 3. So it's going to be 6x plus 15 minus 2 in one bracket. And in the other bracket, it's 2x plus 9. Simplify, we should get the answer 6x plus 13. And then 2x plus 9. And that is the final factored form. Moving on to example 4. So example 4 is we're going to factor using the difference of squares pattern. So the difference of squares pattern, again, that's where you have it's a squared minus b squared, okay, which then factors to a plus b and then a minus b. So that's what we're going to do, okay? So we're going to change using let statements again. For example, a, we'll change the 3x plus 4 so that it's a, and then the 2y minus 1, we'll change that so that it's b. So we're going to go let a equal 3x plus 4 and b equal 2y minus 1. Okay, so now that we've said that, we can now redistribute. So we can go a squared minus b squared. Well, again, a squared minus b squared as written at the top. Well, that's going to be a plus b, a minus b. Substitute the values back in. So we have 3x plus 4 plus 2y minus 1. So again, that's one set. And then you're going to write the second part. So again, it's 3x plus 4. But this is going to be minus 2y minus 1. Okay? So again, what you're going to do is you're going to drop the brackets and combine all like terms. Once you've done that, that should be your final answer. So the first one is going to be 3x plus 2y plus 3. And then the other one is going to be 3x minus 2y. Okay, but now because it's minus 2y, because you actually have to distribute this negative into the bracket here. So it's going to just switch all the signs there. So that's where you get the negative 2y from. But now it's going to change this negative 1 so that it's positive 1, because a negative times a negative gives you a positive. So now it's 4 plus 1, which is 5. And that is your final answer. Okay, last one for B. So this is 27 2x minus 3 squared minus 75 times y minus 4 squared. So again, same thing. Let a equal 2x minus 3, and let's have b equal to y minus 4. So it's going to be 27 a squared minus 75b squared. So before we do anything, because we're going to try and factor this using a difference of squares, we need to make sure that our coefficients are perfect squares. So before we do anything, we're actually going to factor out a common factor between 27 and 75. Okay, that common factor is 3. So we're going to factor out a 3 from each one. So 27 divided by 3 gives us 9, and this is a squared, minus 75 divided by 3. That gives us 25, and then b squared. And now we can factor using a difference of squares. So it's going to be 3 times 3a plus 5b. And then it's 3a minus 5b. Same thing as before. We can now reintroduce or substitute back in 2x minus 3 and y minus 4. So this is going to be 3 times 2x minus 3 plus 5 times y minus 4. Okay, and then it's same thing, 3 times 2x minus 3, but this time we minus 5 times y minus 4. Okay, so you're going to distribute every coefficient now into the bracket, okay, but leave this 3 out. Okay, so leave it factored out. Everything else inside the brackets, that's what you'll work with. So it's going to be 3, okay, so what do I mean by that? So you go 3 times 2, 3 times negative 3. So you're going to do all this here. Okay, once you've done that, then you simplify, and that'll be your final answer. All right, let's do this. So 3 times 2 gives us 6x. 3 times negative 3 is negative 9, plus 5y minus 20. That's your first one. Second one is, again, 6x minus 9. And then it's going to be minus 5y. And this time it'll be plus 20. Okay, so let's clean it up, combining like terms in each bracket. So it'll be 6x plus 5y, and then negative 9 minus 20, well, that gives us negative 29. Okay, and then 6x minus 5y. Okay, and then it's negative 9 now plus 20, so this is going to be plus 11. And that is our final answer there. Now, I've had students in the past say, well, can I write the y first before the x? In that case, it's better if you write it in alphabetical order. So it's better if you write it as, x, y, z, that kind of thing. Okay, so just follow the alphabetical order and go by highest power. Okay? All right. Well, that is it for today's lesson. I really hope you enjoyed it. Tune in next time for lesson 2. Okay, well, we'll talk more about quadratic equations. Until next time, when it comes to math, keep calm and show your work.